In Module 4, Lesson 12, we're going to distribute expressions. We're going to practice more of what we did in Lesson 11. So first of all, we're asked to create a model to show 2 times 5. And then we're going to create a model showing 2 times b. Very basic models. Then in example 1, we're going to write an expression that's equivalent to 2 times a plus b. So that would be a plus b plus a plus b. And then represent a model to represent a plus b. Now the expression 2 times a plus b tells us that we have 2 of the a plus b's. We have 2 of these. So we'll show that as well. Then we're asked how many a's and how many b's do we see in the diagram. Well, there are 2 a's and 2 b's. How would the model look if we group together the a's and then group together the b's? There we have our new model with all of the a's grouped together and all the b's grouped together. And our new expression would be 2a plus 2b. So we can conclude then that 2 times a plus b is equal to 2a plus 2b. Now we're going to substitute. Let a equals 3 and b equal 4. So let's substitute. 2 times 3 plus 4 is equal to 2 times 3 plus 2 times 4. And let's solve and see if that's true. 2 times 7 is equal to 6 plus 8. 14 is equal to 14. Very true. Now if we double a plus b, if a is 3 and b is 4, that is equal to 7, and if we double 7, we get 14. So we continue on. We're going to write an expression that's equivalent to doubling 3x plus 4y. So we would write that as 2 times 3x plus 4y, because doubling is the same as multiplying it by 2. Then they ask us, is this expression in factored form, expanded form, or neither? Now it's in factored form because we have a factor outside of the parentheses. Factor is a number that you multiply. So it is in factored form because we have a factor outside the quantity inside. Now we're going to start this problem the same way we started the first example, and that is by drawing a tape diagram showing our problem. So we have 3x plus 4y. We can change the model to show 2 times 3x plus 4y, or double 3x plus 4y, by doubling our model. Then we see that there are terms that we can combine in this example, so we can move them around, and we'll draw that again. And so now we see that we have 3x plus 3x, which is 6x, and 4y plus 4y, which is 8y. The equivalent expression would be 6x plus 8y. 2 times 3x, which is 6x, and 2 times 4y, which is 8y. And then in summary, when there's a number inside the parentheses, we can multiply it by the terms on the outside. Switch that around so it sounds better. There's a better version. When there is a number outside parentheses, we can multiply it by the terms on the inside. So now we have in example 3 a drawing very similar to our area drawings from previous lessons. They're asking us to write an expression in expanded form that is equivalent to the model below. So we have y that's being multiplied by 4x plus 5. And this is our factored expression, remember, because factored expression has a factor outside the parentheses and then a quantity inside. We can rewrite that expression as 4xy plus 5y. We're multiplying 4x times y and 5 times y. Now let's do the same thing for a little practice in example 4. We'll write an expression equivalent to 3 times 7d plus 4e. So we multiply 3 times 7d, giving us 21d, and 3 times 4e, which will be 12e. In the exercises, they ask you to draw a model for each of the expressions and then write another equivalent expression using the distributive property. So I'll do the first one with you in terms of the model, and then so in our first model we have x plus y and x plus y and x plus y, or 3 times x plus y. And then in the second model, I've moved all the x's together, x plus x plus x plus y plus y plus y. So our expression then can be 3x plus 3y. Now as you work through the second example, make sure that you draw your tape diagram the same way I did in exercise 1. And then your second example, or exercise, what you should have is 8h plus 4g when you're finished. And then finally, we're going to use the distributive property to write equivalent expressions in 3 through 8. So we don't need to draw the diagrams for these. 8 times h is 8h, plus 8 times 3, which is 24. There's an equivalent expression. In number 4, we have 3 times 2h, which is 6h, plus 3 times 7, which is 21. And then in number 5, we have 5 times 3x, which is 15x, plus 5 times 9y, which is 45y. In number 6, we have 4 times 11h, which is 44h, plus 4 times 3g, which is 12g. In number 7, they've given us the drawing, so we'll have to write the expression first. We'll have j times 7k plus 12m. And then to solve that, j times 7k would be 7jk plus j times 12m, which is 12jm. And if you have kj, that's fine, or mj, that's okay. Normally we write our variables in the order that they appear in the alphabet. That's why I put it as jk and jm. And finally, number 8, a times 9b would be 9ab, again, in the order that they appear in the alphabet. And a times 13 is 13a.